Hi everyone, this is your math guru. In this video, I'm going to show you how to find the derivative from first principles. In the first example, we have determine the derivative of y equals 3x squared from first principles. We have our f of x is the same as y, which is equal to 3x squared. The formula to use is we have f prime of x equals limit as h tends to 0, f of x plus h minus f of x all over h. Already we've found our f of x to be 3x squared. Our f of x plus h, wherever we have the occurrence of x, we're going to add h. So this is going to be 3x plus h all squared. So slotting it back into the equation, this is the equation we're using. We have f prime of x equals limit as h tends to 0. F of x, we have it as 3x plus h all squared minus f of x, which is 3x squared, all over h. I'm going to expand 3x plus h squared. This is the same as 3x plus h, x plus h. This is the same as 3 in bracket, x squared plus 2xh plus h squared. And that will give us, if I FOIL or expand, multiplying each term by 3x squared plus 6xh plus 3h squared. So I'm going to replace that in my equation. I have f prime of x equals limit as h tends to 0, 3x squared plus 6xh plus 3h squared. I'm replacing it with what I have here, minus 3x squared all over h. If I check, 3x squared minus 3x squared cancels out. I'm left with limit as h tends to 0, 6xh plus 3h squared all over h. If I factorize h at the top, I have my limit as h tends to 0, h in brackets, 6x plus 3h over h. My h cancels out. I have my f prime of x equals limit h tends to 0, 6x plus 3h. And as h tends to 0, the value of 3h here will also tend to 0. So therefore, our f prime of x will be equal to 6x. Let's look at another example. In the second example, we have determined the derivative of y equals x squared minus 4 from first principles. Like we did earlier, our f of x is equal to y, which is equal to x squared minus 4. The formula we'll be using from first principles is f prime of x equals f of x plus h minus f of x. Oh, I forgot to put my limits. I'm going to correct that. I have my limit as h tends to 0, f x plus h minus f of x all over h. Already we know of f of x to be x squared minus 4. So our f x plus h, wherever we have x, we're going to add h. X plus h all squared minus 4. If I expand, I'm going to have x squared is the same as x plus h, and that will give us x squared plus 2xh plus h squared. So if I slot that back in, just to make my equation simpler, I'm going to have x squared plus 2xh plus h squared minus 4. That will be my fx plus h after expanding. So if I slot that back into the first principal equation, that will give us f prime of x equals limit h tends to 0, fx plus h. Now I have x squared plus 2xh plus h squared minus 4 minus f of x. My f of x is, I'm going to put that in a bracket, x squared, because it's an expression with more than one term, over my h. If I open up the bracket, I'm going to have limit h tends to 0, x squared plus 2xh plus h squared minus 4 minus x squared plus 4 over h. X squared minus x squared cancels out, minus 4 plus 4 cancels out. I'm left with limit h tends to 0, 2xh plus h squared all over h. If I factorize, I have a limit h tends to 0. I'm going to take out h, which is common to both terms, 2x plus h all over h. My h cancels out, so therefore my f prime of x equals limit h tends to 0 to x plus h. And as h tends to 0, the value of h here is also going to tend to 0. So therefore, my f prime of x will be 2x. Thanks for watching. Bye.